Hello everyone. Today in this session we will learn about matrices. How can we define matrices in R? In the last session we have seen how can we define certain kind of vectors and how can we convert an object of different data types into another. For example, in the last class we have seen how we can convert an integer into logical, how can we convert an integer into numeric, and how we can see in case of character we cannot convert them into complex or maybe numeric or maybe logical, because in that case it has generated any value. In simple terms, we have seen that if R is not confirmed, then it generates warning sign along with that any value. So today we are discussing matrices. In simple words, we can say that matrices are nothing but vectors with dimension attributes, that is number of rows and columns. We have seen that if we are defining a matrix that consists of rows and columns, so in this case I'm just using as a comment in this case. But one more thing, you can say that in case of R, matrices are nothing but a combination of vectors. So for example, if I'm saying vector, it is one-dimensional matrix, or if I'm saying matrix, then it is multi-dimensional vector. So these things you can use in your case. So in simple words, we can say that vectors with dimensions, that is rows and columns, are defined as matrices. So in this case, for example, I am defining my first matrix. Either you can write matrices or you can say matrix, it depends upon you. So in this case I'm using a keyword that is known as matrix. So for defining that matrix, first I'm creating an empty matrix. So if you want to create a matrix with the data, then you can define the data in the form of numbers or maybe any other thing. But right now I'm just showing the definition of matrix, that is vector with dimension attribute. So I am creating a null matrix that do not consist, or empty matrix that do not consist of anything, and I'm just defining rows, that is 2 rows, and I'm defining columns. So n col is defined by 3. So in this case you can see the size of the matrix is 6, 2 into 3, that is 6 rows into columns. So in this case you can see a matrix has been defined, my matrix. So in this case the values are 1 to 2 and 1 to 3. So these kind of things are there, and if we want to print this particular thing, so matrix, so what will be the answer? Because nothing has been given, so it is nothing but empty thing or not applicable. I have not mentioned the name, we can change the name of these particular things. So it is defining first row entire columns, second row entire column. So in this case entire row first column, entire row second column, entire row third column. So these kind of representation we can use in this case. So if you want to find out the dimension of this particular matrix, as I earlier told you, the dimension means 2 into 3, that is 6 particular values are there, because it is an empty matrix, but it doesn't mean it doesn't have any dimension. So for that dimension thing, we use a keyword that is known as dim for dimension. And what was the name of my matrix? My matrix. So in this case my matrix has been used and I'm using, so it has 2 rows and 3 columns, which we have already defined in our this. For example, the matrix already has been defined, I'm just using it by their variable name. So in that case I'm just providing the name of the variable in which matrix has been stored, and it will show me the dimension by using dim. So another thing that you can keep in mind regarding the attributes that are available in case of matrix. So in this case, what was my matrix? For example, my matrix, in this case I'm just typing my matrix. So in this case, what are the attributes? Again, in this case directly you can fetch 2 rows and 3 columns. So by using $dim, you can see in this case it is showing me the attributes same as that of dimension. So both the things we can use for finding out number of rows and columns that are available. So rather than using a blank or an empty matrix, we are using a field that consists of data. For example, I have used an rather than speaking, I am just using that particular thing. So my second matrix I'm creating, and in this case I'm using a keyword again, that is matrix. for defining a matrix, and then I am providing a data. So instead of saying data is equal to something, I am providing a range. So range is nothing but an integer. So in this case again, so 6 values are there, we have to make corresponding rows and columns. So 2 3 just 6 or 3 2 just 6, all the things are there. So n row is equal to 2 and n col is equal to 3. So 2 into 3, that is 6. These are there. So it automatically assigns my second matrix. In this case, it has been shown the values, you can see in this case 1 2 3 4 5 6. So here it is filling the matrix in the form of columns. So we can define it in the future that how can we fill the values row wise, or how can we by default fill the values in columns. So here a command you can also use, that is view my second matrix, or maybe directly view my first matrix. So what was the name of my first matrix? My matrix. So this was there, my matrix. So if you want to see that, automatically it will give me this. So all the values are nothing but NA. So I'm just removing it so that you can get an idea what kind of things we are talking about. So in this case, if you want to directly see that matrix, so we can use print my second matrix, or you can simply type in the console my second matrix. It automatically reflect me that. Instead of saying view method is there, or the shortcut thing is there by which we can see variable 1, variable 2, variable 3. These are the parameters that we will use in data science. That what are the parameters that we have to keep in mind, and 1 and 2 represent the entries, that is number of rows. So v1 v2 v3 represent the columns. In this case I am just removing it, and after that we can see a matrix can be created directly from vectors. So in the earlier, that in the starting of this particular video, I've told you that matrix are nothing but multi-dimensional vector. So matrix can be created directly from vectors by adding a dimension attribute. So dimension means rows and columns are there. If you are adding towards that particular thing in the vector, that it will automatically convert that vector into a matrix. So in this case you can see it's a vector thing, 1 to 6, all the values are there. But if we have defined in attribute or the dimension thing into this, automatically it will convert that particular thing vector into a matrix. So I am using another example by which my vector is there, I am converting that into a matrix. So my vector has been defined and it consists of 11 values, and you already know that the rule says that final value minus lower value, or you can say maximum value minus minimum value plus 1, this is the condition. So you can see my vector in this case total 1 to this integer value is there. So in this case I am just converting them into a, you can say, matrix. Either the first way was by using matrix only, or the second way is to use a vector and providing the dimension. So I'm saying that there is a vector known as my vector that consists of values from 1 to 10, and I am assigning a dimension. Dimension is in the form of rows and columns, and whenever we are assigning rows and columns, the earlier method was by using n row n column, or the second method was by using a vector that 2 rows are there and 5 columns are there. So this is the second way by which we can assign. So in this case you can see the my vector has been changed towards this 1 and 2, that is 2 rows are there and 5 columns are there. So when I click on this, you can see 5 columns are there and 2 rows, and again it is by default filling the matrix in the form of vertical manner. So in this case we can see, we can directly see that. So what was the name of my vector? So my vector, so this was the name of my variable. So in this case the same thing which I have showed you, in this case also it is written. So 1 2 in the vertical manner, then 3 4, then 5 6 7 8 9 10. So when we use the term dimension and allocating that particular vector dimension in the form of rows and column, it can give me a matrix. Or the second method was, or the first method was by using a key term that is known as matrix and providing rows and columns into that. So these are the two methods by which we can create a matrix. One more thing you have to keep in mind, that matrix can be created by column binding or row binding method. So there is a third way also. First was by using a keyword that is known as matrix, second is by the use of vectors, and third by the use of column binding and row binding method, in which we are using row binding rbind keyword and cbind for column bind functions. So third thing we are using, the first one was using a matrix, so I'm just listing, I will summarize it at the end. Before that, I'm just showing you how can we use rbind and cbind method. So it is r small r bind, because r is a case sensitive language, so it's cbind. So in this case of third method, we are using rbind and cbind. In this case, first we are defining x, or maybe some other variable we can take, for example o1 we are taking, and we are assigning an integer that is 1 to 10 in this case. Another thing that we are taking another variable, for example p1 we are taking in this case, and we are assigning 11 towards 20, or maybe 11 towards 20. Two different vectors we have defined. So in this case, or you can say a range operator has been defined. O1, it consists of integer from 1 to 10, and other, that is p1, which consists of value from 11 to p1, that also consists of 10 values, maybe 10 minus 1, that is 9, plus 1, that is 10 value, and it consists of 11 to 20 values. So in this case it is showing. Now I am using cbind and rbind method. First we are binding it by column wise, so but we have to provide the variable name, so it is o1 comma p1. So first o1 vertically, and then second one is p1 vertically. So you can see in this case, so cbind, if we want to allocate that same thing into another variable, for example we are saying l1, so automatically you can see the reflection. In this case it consists of nothing like a matrix thing which we have earlier done. So here in this case it is showing the binding in the form of L1. I can directly type it, and you can see here O1 has been just binded with another P1 in the form of column manner. So if you want to do the same thing in, you can say, row wise manner, so I am assigning not assigning certain values, I am just directly doing, rather than C I am using R, and I am just binding O1 with P1. So in this case you can see O1 with P1, so it has been allocated. If you want to save that particular while, and you can assign a name of the variable, so it is L2 in this case, and it has been allocated towards this particular value. So here you can see two rows are there and 10 columns are there. In case of L1 there was 10 different rows and 2 columns are there, so this is 10 rows and 2 columns are there. In case of rbind, because we have merged it in the form of rows, so here it is 2 rows and 10 columns. So this thing we have done by the use of R. So at the end I am just summarizing it. There are 3 different ways by which we can create a matrix in R. First, by the use of a keyword that is known as matrix, by providing n row, that is number of rows, and number of columns. The second method that consists of using vectors, in which we are combining vectors and providing the dimensions. So, and the third method is cbind and rbind method, where we are combining vectors or the values in the form of column or maybe in the form of rows. Thank you so much.